Hello, my name's Tom. I'm going to be doing the next few lectures in the TYC Materials Modelling course. And today I'm going to be talking about a few different topics. And in this talk, I'm talking about crystal structure. I think crystal structure is one of these things that's a bit easier to understand if you look at a few examples. So that's what we're going to do today. If you have access to a UK institution, you should be able to log into this website here, the Physical Sciences Data Service, where we have access to this ICSD database. And we can look up any crystal structure we might be interested in here. So I'm going to use magnesium oxide as my first example because it's a nice simple structure. I can just run this search and find the crystal structure it has. So there we go. This first result here is fine. This is the MgO crystal structure. So if we click the Visualize tab here, we should be able to actually see it. Looks like this. But we can download a CIF from this website. So CIFs are a very detailed file format that contains a lot of details about the crystal structure that's normally kind of worked out from experiment. But if we want to visualize those, we normally just need to quickly convert them into something that the visualizer will be happy with. So I've written just a quick Python script here that converts these CIF files into a format that the visualizer is happy with. I'm going to use VMD today, which is a bit of a pain to learn, but it's a very, very powerful visualizer if you can get the hang of it. So I've opened up this MgO structure and I'll just change the display options a little bit. Just ask it to show us the cell as well. I need to consult my notes. PBC box, there we go. So this is an MgO crystal structure. You see that it's defined both in terms of these atoms, which have their own positions, but also in terms of this unit cell, which is shown by the blue box here. If I jump back to the lecture notes, to slide 11. This is what this, if you're a visual learner, this is just exactly what this slide is saying, that the crystal structure is defined by a lattice, the unit cell, and by a motif, the atoms within the cell. So jumping back to our example, you can see the blue box is the unit cell and the atoms that we can see are the motif. So what this kind of representation represents is actually an infinite crystal, because we have periodic boundary conditions, and this unit cell is completely surrounded by periodic images, repetitions of the structure. So I can ask this visualizer to draw some of these repetitions. See that it just happily sets to work drawing them. We can obviously just keep on increasing the amount that we draw. And I guess we see the kind of infinite crystal. So although the entire structure is defined just by the unit cell, what we mean by such representation is actually that the infinite crystal that I just kind of showed a visualization of. And different combinations of atoms will produce different structures. So I've also downloaded the structure of diamond, which I'll now visualize. In the same way. PVC box. Diamond has a structure like this, which is maybe a bit harder to imagine, at least for me. But again, if we toggle on some periodic repetitions, oops. See, it's got this quite complicated networking structure where you have diamond tetrahedra. So each of these carbon atoms is linked to another 4 carbon atoms in a kind of pyramid-like shape. And we don't also get crystal structures that are kind of like this, but we also can have molecular crystals. So I also downloaded the crystal structure of Buckminster Fullerene, which is going to be much harder for my poor old laptop to visualize, but we'll have a go. This is an example of a molecular crystal where we have these C60 molecules, these Buckminster Fullerenes, and they've been arranged in a crystal structure by just repeating the molecule over and over. So if I add in one repetition, we should be able to see one of these whole molecules. It's this sphere in here. This particular structure, if you can see it, is actually a face-centered cubic arrangement of these giant carbon footballs. So, I mean, that was 3 practical examples, but whenever we're describing crystal structures, it's always going to be described by a combination of a lattice, a unit cell, and some atomic positions or a motif. And using this definition, we can build up any crystal structure we might be interested in. Let's put a few other couple of examples here. Just one important point, of course, is that this unit cell doesn't have to be a cube. It just makes life a bit simpler if it is, but there's lots of structures that don't have that. So here I've got an aluminium oxide structure.